everyone! So today's video will be talking about file inclusion. So file inclusion is this vulnerability that is, like its name says, it's about including files. But there are more like 3 different types of file inclusion vulnerabilities. So one is local file inclusion, or LFI. Second would be remote file inclusion, or RFI, and the directory traversal. So file inclusion vulnerabilities can be found in web applications that request access to files. Those files could be images, static text, and so on. And those files are requested through parameters in query strings attached to the URL. So a part of the URL, like for example here, you have the parameter who is file and then its value. So for example, parameters are used with Google searching, like here where Q is the parameter. And we can discuss this scenario where you have a user wanting to get access to the file user cv.pdf, so it sends the request to the web app server, and then the server will go look at where the file is and then send it back as a response. So why do file inclusion vulnerabilities happen? File inclusion vulnerabilities occurs due to poorly written code and that takes user input as a parameter with no input validation or sanitization. So in those cases, file inclusion vulnerabilities are commonly found and exploited in various programming languages for web applications such as PHP, GSP, ASP, and so on and so forth. So now, what is the risk of file inclusion? And as we say a lot in this field, the answer is it depends. Yes, if the attacker can use file inclusion vulnerabilities to read sensitive data, in that case, the successful attack causes to leak sensitive data, including code and files related to the web applications, credentials for backend systems also. Moreover, if the attacker somehow can write to the server, then it is possible to gain remote command execution, or RCE. However, it won't be effective if the file inclusion vulnerability is found with no access to sensitive data and no writing ability to the server. So let's see the first attack, which is the path traversal, but also known as directory traversal, or also the .. So this is an attack or vulnerability that allows an attacker to read operating system resources, such as local files on the server running the application. And the attacker exploits this vulnerability by manipulating and abusing the web application's URL to locate and access files or directories stored outside the application's root directory. Path traversal vulnerabilities occur when the user's input is passed to a function that reads the content of a file, such as file get contents in PHP. So you have to know that the function is not the main contributor to the vulnerability. It's often poor input validation or filtering that is the cause of the vulnerability. And in PHP, you can use the file get contents to read the content of the file, but it's not just in PHP. So let's go back to this example. So a normal user would request the content of the user cv.pdf from the defined path, which is /var/www/app/cv and then you get to the file. So we can test the URL parameter by adding payloads and see how the web application behaves. Path traversals attacks, also known as ... attack, take advantage of moving the directory one step up using the double dots here. So if you go here, as you can see, so you get 2 dot and then a slash, then 2 dot and then a slash, and so on and so forth. The attacker is trying to get to the /etc/password file, and what he does is trying to get from the original directory. So the original directory that the web app is searching in would be the CV one, and go all the way to etc/password. So we know that the current path is this. So if you want to go all the way to this file, we'll have to go by 1, 2, like 2 dots, then slash, then again 2 dots to get to www, and again 2 dots to get to var, and again 2 dots to get to slash, and then we'll add the rest of the path, which is etc to get to the etc directory, and then the name of the file, passwd. And as a result, the web application will send back the file's content to the user. So the attacker sends its request like this, and then the web app will send back the password file content. Similarly, if the web application runs on a Windows server, the attacker needs to provide Windows paths. So for example, if the attacker wants to read the boot.ini file located in this directory here, then the attacker can try the following: either put in this or this, depending on the target OS version. And sometimes developer will add filters to limit access to only certain files or directories. So here we will look at some common OS files you could use when testing. So etc/issue, which contains a message of system identification to be printed before the login prompt, /etc/profile, which controls system-wide default variables such as export variable, file creation masks, terminal types, mail messages to indicate when a new mail has arrived, proc/version, which specifies the version of the Linux kernel, etc/password, which has all registered user that has access to a system, etc/shadow, which contains information about the system's users' passwords, root/.bash history, which contains the history commands for root user, var log dmessage, contains global system messages, including the messages that are logged during system startup. There's also var mail root, which contains all emails for root user, and this one contains private SSH keys for a root or any known valid user on the server. There's also the /var/log/apache2/access.log, which the access requests for Apache server, and also boot.ini, which contains the boot options for computers with BIOS firmware, and this one is for Windows. So let's talk about LFI, or local file inclusions. LFI attacks against web applications are often due to a developer's lack of security awareness. With PHP, using functions such as include, require, include once, or require once. They often contribute to vulnerable web applications. So here we'll be picking on PHP. However, as a reminder, LFI vulnerabilities don't occur only when PHP is used. It can also occur when using other languages such as ASP, GSP, or even Node.js apps. And also, LFI exploits follow the same concepts as path traversal. Let's suppose there's a web application that provides two languages, and the user can select between EN for English or AR for Arabic. So this PHP code uses the GET request via the URL parameter lang to include the file of the page. So the HTTP request would be as follows. Here we go. Or like this if you are searching for the Arabic language. And both the en.php and ar.php files exist in the same directory. So theoretically, or in theory, if there's no input validation, we can access and display any readable file on the server. So let's say we want to read the /etc/password file. We can try this, like put in the path. And we know that this file contains sensitive information about the users of the Linux operating system. In this case, it works because there isn't a directory specified in the include function and no input validation. So let's try it now on the lab. So let's open lab 1 and do it. So in the lab 1 it says include a file in the input form below. Let's say it says, for example, welcome.php. Let's just put welcome.php and see what we get. So as you can see, we get file content preview of welcome.php, welcome to THM, current path, it gives you the current path too. And if you go look at the URL, there is the welcome.php here. So let's just try with something that doesn't exist, that probably doesn't exist. And we get errors, and it says like include test, and it can't find it, no such file or directory. So anyway, let's change this with etc/passwd and see if we can get it. And yeah, here we go, we have it, we got it. So how did we do that? Because there is absolutely no filter, nothing. We just specified the path in the include function because there is no input validation. Now, let's continue. So next, in the following code, the developer decided to specify the directory inside the function because he was like, maybe we shouldn't let it be just like that and anyone being able to put a path. So they changed it to this code, and here the developer decided to use the include function to call PHP pages in the languages directory only via the lang parameters. And if there is no input validation, again, the attacker can manipulate the URL by replacing the lang input with other OS sensitive files, such as, again, /etc/password. Again, the payload looks similar to the path traversal, but the include function allows us to include any call files into the current page. So the exploit would look like this. Let's try it again, this time on lab 2. So we open lab 2. So again, it says include a file in the input form below. So let's just do the same as before, like welcome.php, and see if there's something different. So same as before, we get welcome.php here, and it says the current path is this. So let's put something that doesn't exist to see if something changes. And as you can see, if before it was include test, now it's include, and we have the directory includes slash the word that we used. So that means we aren't on var www./html, but we are on var/www/html/includes, which means before that, let's just try to do the same as before and see if it works. It shouldn't, but let's try it anyway. And it doesn't. You see, we have it just put the it just concatenates the /etc/passwd to the directory includes, which means if we want to get there, we need to go all the way back to the slash. So we would add 2 dots and a slash to get out from includes, then again 2 dots and a slash to get out from HTML, then 2 dots and a slash to get out from www, and again 2 dots and a slash to get out from var, and then we add etc/password to be able to get there. Let's see if I'm correct and if I didn't miss 2 dots and a slash or not. And yes, I was correct. There was enough dot slash. Anyway, that's how we got it. Next. So until now we were able to check the code for the web app and knew how to exploit it. And we call that white box testing. However, in this case, so in the following cases, we don't have the source code. So we are performing what we call black box testing. In black box testing, errors are significant in understanding how the data is passed and processed into the web app. So in this scenario, we have the following entry point, which is this. And if we enter an invalid input, such as THM, we get the following error, this thing. So this error, we can see that the include uses the directory languages, and also there is the t.php that was added to THM. And another thing is this other important part of the warning or the error message, which says in which directory we are located. So here we are located in the var/www/html/thm4. So to exploit this, we need to use the // trick as described in the directory traversal section to get out of the current folder. So we'll try something like this, and we use // 4 times because we know that the path has 4 levels, but we still receive the following error, which is here. So we get again this .php that is appended to the end. And to bypass this, we can use the null byte, which is this, so %00. And using the null byte is an injection technique where URL encoded representations such as %00 or 0x00 in hex with user supplied data helps to terminate the string. So by adding the null byte at the end of the payload, we tell the include function to ignore anything after the null byte, which may look like this, and it is equivalent to this. So as if the .php wasn't there. So you have to know this trick is fixed and not working with PHP 5.3.4 and above. So let's try this on lab 3. So let's open lab 3. Again, let's just put something that works. Here works. We get to see the welcome here in the parameter file. So let's try something that doesn't exist again, and we get to see that we are in the path like the includes. So if we wanted to go all the way to etc/password, we have to go back. So 1 time, 2, 3, 4 levels. So we'd be doing something like this, just like before. 1, 2, 3, 4. And we get this. So we still get an error. And this error says, like, we put etc pass wd, but it added the .php at the end. So we need to remove this .php. Like, how do we do that? By adding the null byte. And here we go. So we got it. Okay, we're on lab 4, same as before. We'll try to include something that works. It works. Now the URL is the same. Let's try to include something else that doesn't exist. So here, file get contents welcome, and it says no such file or directory in the current path. So /var/www/html. So what we should do is same as before, put in the 2 // how many times as we need here. There are 3 levels that we need to get up to. So 1, 2, 3, and we'd want to do this and see the result. So what it says is you are not allowed to see source files. So in this case, so what we can see is the etc password file is being filtered. And there are 2 possible methods to bypass this filter. One is by using the null byte, and the other is using the current directory trick at the end of the filtered keyword. And the exploit would look either like this or like that. So let's do that. If we want to do the current directory, let's do it. As you can see, just by putting /dot at the end, we get the answer. So just for you to know, if we were like, for example, when you're here, there is two ways of either you go up like one level by putting cd then two dots. That's what we were using when we were doing like dot slash. Or if you put one dot only, that means we stay in the current directory like this. As you can see, I didn't change directory. Just by putting cd one dot, I still am in the same directory, which means by using that's why we use this at the end, like the slash dot. Now, I said that we could also use the null byte, and as you can see, yeah, it also works. Now the developer is fed up and he starts to use input validation by filtering some keywords. So if we try and do the same, we would get the following error message, which is this. So as you can see, the dot slash, or all the dot slashes have been removed, and we end up with this. So they have been replaced with empty strings. So there are a couple of techniques that we can use to bypass this. One of them would be to just send this. So why does this works? It works because the PHP filter only matches and replaces the first subset string it finds and doesn't do another pass, leaving what is here like this. So let's try it out in lab 5. Again, we'll try something that works, then something that doesn't work. And we see that here when it doesn't work, it says that we are in the includes directory. There are 4 levels, so 1, 2, 3, and 4. So let's do this like this and see if it works. Oops. And we get this error message that we talked about. So what do? Let's try and put the same, like the dot slash to each time twice, but it doesn't remove what we want to get. And here we go. We got it. Preview file. We got the information that is in the file etc/password. Now, here the devs are really fed up with all our shenanigans. Like, truly, we've gone a bit too far. Anyway, they decided to force the include to read from a defined directory. For example, if the web application asks to supply input that has to include a directory such as this, so languages/en.php. So to exploit this, we would need to include the directory in the payload like so. So we put languages here, the directory that is asked of us, and then as many as needed // to get all the way to the file that we want to get to. So let's do that in lab 6. So here it says we have to put the THM profile directory first. So let's try and put exactly what it says. So THM profile, no, what did it say? Tryhackme.txt. And that's what we get. So let's do the same, but this time, instead of putting something that is there, let's put something that isn't there. So again, and we get the include. So we have THM profile dot Tryhackme doesn't exist. We need to so that's it. And if we don't put THM profile directory, it says access denied, allowed files at THM profile folder only. So we'll change this and put it like this. So we are in that directory. We add all the needed ... so there are 3 plus THM directory. That means there are 4 levels. And here we go. Does it work? Will it work? Hopefully it works. And nope, it doesn't. So it says allowed files at THM profile folder only. So maybe let's put this at the end, or maybe it asks for something. And here you go. That was it. Case sensitive. Anyway, so I just want to verify without it. Yeah, it was just because I didn't write THM in uppercase. Anyway, so we got the file, and there's a question asking us for the file OS release, I think, or oh no, it's not, it's lowercase, and we get the file. So now we've talked about LFI and we've talked about directory path traversal. They look exactly the same, but they are different. So what's the difference between the two of them? In directory path traversal, it only allows the attacker to read the file, doesn't execute the file. While in LFI, that would execute, like include the file in the PHP code, and that will execute it. So that's the difference. Let's continue. Remote file inclusion. So remote file inclusion is a technique to include remote files into a vulnerable application. So when does it occur? It occurs when, again, user input isn't properly sanitized, allowing an attacker to inject an external URL into include function. And another requirement for remote file inclusion is that the allow URL fopen option needs to be on. The risk of an RFI is higher than one for the local file inclusion, as it allows an attacker to gain remote command execution on the file server, or RCE. It can also disclose sensitive information, or the attacker could get and cross-site scripting, or denial of service. For a successful verify, an external server must communicate with the application server, where the attacker hosts malicious files on their server. Then the malicious file is injected into the include function via HTTP requests, and the content of the malicious file executes on the vulnerable application server. So if I was an attacker, I would send the request with the parameter files, but if you can see here, what we see this is it links to the server, the attacker servers, and then the web app will send a request to the attacker servers to get that file, that cmd.txt. The web app server will send back this file. So here it's just not much, it's just php echo hello thm, and send it back to the web app. Then it injects the content of cmd.txt into include function and execute it, and send back the result of execution within get.php page. We'll see more about how to do the remote file inclusion in the challenge. For now, let's talk about remediation. As a developer, you know that it's important to be aware of web application vulnerabilities, how to find them, and prevention methods. So to prevent the file inclusion vulnerabilities, some common suggestions include keep system and services included in web application framework updated. Turn off PHP errors to avoid leaking the path of the application and other potentially revealing information. A web application firewall is a good option to help mitigate web application attacks. Disable some PHP features that cause file inclusion vulnerabilities if your web app doesn't need them, such as allow URL fopen and allow URL include. Carefully analyze the web application and allow only protocols and PHP wrappers that are in need. Never trust user input, and make sure to implement proper input validation against file inclusion. Implement whitelisting for file names and locations, as well as blacklisting. And for more in-depth testing and remediation techniques, you can go look at OWASP Web Application Security Testing 4.2. It's the latest version as of today, and I'll be linking it in the description box. So let's go and do the challenge. So what's the challenge says? It says just like first, what are the steps for testing for an LFI? Find an entry point that could be via get, post, cookie, or HTTP header values. Enter a valid input to see how the web server behaves. Enter invalid inputs, including special characters and common file names. Don't always trust what you supply in input forms is what you intended. Use either a browser address bar or a tool such as Burp Suite. Look for errors while entering invalid input to disclose the current path of the web application. If there are no errors, then trial and error might be your best option. Understand the input validation and if there are any filters. Try to inject a valid entry to read sensitive files. So, first things first, capture flag 1, which is at etc/flag1. Let's start with the first challenge. So, let's open here. It says, include a file in the input form below. The input form is broken. You need to send post request with file parameter. Let's just try anyway. Doesn't work. No. Let's see what it sends. It sent the get, but it doesn't work. And they did say that it, like, you need to send post request. So let's just try and do something. So we'll copy this as a curl one, and I'm just gonna change it here first. Yeah, we don't need all this user agent and so on. However, instead of using the get request, we need to use the post one. So that's what I'm gonna do. So I'll add the parameter file in as data for a post request. File equal, and here we go. Let's try with welcome.php. So that's what normally should work. So I'm copying it. Okay, when I do this, we get content preview of welcome.php, welcome to THM. Okay, it works. So now let's do something that shouldn't work because it doesn't exist. It shouldn't exist, or maybe it does, but hopefully it doesn't. And yeah, it doesn't exist, as you can see, but we get the error message. So what the error message says, include test. That's what we asked for. It says fail to open, like no such file or directory. And we have what we wanted to know, where we are, like what is the current path. So the current path is var www/html, which means we have three, we have to move like up by 3 before we get to etc. So let's do that. 1, 2, 3, and then etc, and then it asks for flag 1. And yep, we got the first one. Okay, let's get to the second challenge. The second challenge asks for, it says that the flag is in etc/flag2. Let's open challenge 2. Challenge 2. It says include a file in the input form below, but there's nothing. So it asked for refreshing. I refreshed, and it says welcome guest. Only admins can access this page. Let's see what was sent here. So I'm just gonna refresh again and see if there is anything. Like it told us, like we were talking about just before, like the different ways, different entry point that we have to look for. One of them being the cookies. And because it says welcome guest, only admins can access this page, probably the information is in the cookie. So, and that's what we see. We see that the cookie is guest. And it says only admins can access to this page. So we should change this cookie to, instead of guest, to admin and see if it works. We want to change the cookies. Let's choose Burp Suite. I'm gonna use it. So burp. So let's start by intercepting the request. Okay, I'm just gonna open the browser and do it directly here. So okay, let's just forward this, then refresh, and here we get it. Okay, as you can see now, we got the packet that we saw before, and let's just change guest from guest to admin, the cookie that we had. So, and forward it and see what happens. Okay, so here this is the admin web page, get the flag, welcome admin, and it says the current path is var www/html. Good. Let's go back to history and the last one and modify it. So I'm sending it to repeater to be able to change the cookie and see the end says. So instead of admin, let's try something else like flag 2 and see what answer we get. So as you can see, we get this answer, which is okay. It says include a file in the input form below. Yeah, so no such file or directory. And we are, so it's, if we look at the warning, the errors, it says includes flag.2.php. So first things first, when I put flag 2, it added .php here. So we should probably add the null byte at the end. But also, it's in the directory includes, which is all like HTML www var. Like let's try and do the same thing as before. So here, instead of flag 2, I would need to put 4 levels, I think. And then at the end of flag 2, I do need to put the null byte. And let's try it again. Do we get the results? No, there's an error. So probably I put too many ... Let's look with 3. So with 3, do we get a warning? Yes. Oh, I forgot. It's not flag 2. It's etc/. That's so me. Okay. Let's look here. So there is still probably, I still need one. Oops. So here we go. Send that. And let's see the answer. And yes, we got the answer. So here's the flag. Now let's look at challenge 3. So let's open challenge 3. Here it says, for example, let's just put something that should work and see what's the result. Okay, works. Let's put something that doesn't work and see what's the result. And here it says fail to open stream no such file or directory in this. Okay. So we know that the flag 3 is in etc/flag3. And when I put file like test, it's added .php. So again, we'll need the null byte to try using the null byte and see if it works. So I'm just gonna put test and then the null byte just to see if it removes it. So let's try putting it here instead of there. Nope. So there's something going on, and probably okay, let's still try also if I can just put like this. Okay, there's too many. So at least we know that there is like 3 levels to go back. And then here you go. Let's see. Nope. If you can see here, it does remove the slash and the .. So let's try add in same as before and see if it works, and put 2/ here. Nope. It's still the same. Okay, so in the get like if I send it in a get, apparently it doesn't work. Let's see if let's try modifying it here and see. So it does send it like this. I'm sure about that. And we still have this, which means the verification is on the server side. the input validation is on the server side. I can't modify it from my side, but it uses the get method. What if instead of using the get method, we used a post method? So I'm just gonna try that. Remember, we're in curl, so using curl. Where did I? Oh, here you go. So curl, and the name of the parameter is still file. Let's just try it like this and see if it works. Okay. It's fine. Okay, let's send this, and we get this. So no answer. Oh. So here it tries to preview the place where we like flag3 file. However, there's still the .php at the end, which means we have to use the null byte and see if it works. And yes, it does. And we get the answer. So the post one was working. Now on to the last challenge. The last challenge says gain RCE in lab playground and with R5 to execute the hostname command. And what is the output? So if we want to do an R5, we need a server. So I'm gonna start a web server on my machine. To start a web server, I'm just gonna use Python 3 HTTP server. Here we go. So it's listening on port 8000. And I need to create a file on that place, like on my web server, so I can use it for the remote file inclusion. But before that, here it is. Open this. So here, let's try just put in anything. It's trying to get to test.php, that's the file I put, but let's do something else. And it says that, oh, there isn't any file like that. But how about can we get to etc password? Yes, we can get there. So like this, nothing different. But and before that, I just want to verify that my web server is working. Yes, there's everything that is there, which, yeah, whatever. So I'm just gonna put in this in the directory where the web server was created a new file, a PHP file. So So it did ask us to get the host name. So that's what I'm gonna do with this. Let's try and see if it's still here. Okay. Copy link. So now, okay, I can't use localhost. Why, you say? Because localhost is on my machine. It's my IP address. But I can look at what is the IP address for my for the right interface, network interface. So if config, and this is the IP address. Let's put it here, and yes, here we go. So we got the hostname command. We were able to execute the hostname command by creating this file, which is here. Let's just, here you go. So this PHP file where there is just print exec hostname, and it shows the answer. So you could use the file that we created and we put on the web server to put any command that you're used to use on a Linux machine as the web server that here, I mean the victim, the target web server, which is at this IP address, uses a Linux one, as we could see the paths which are like Linux paths, and put like who am I, if you wanted you to know who, like what's the name of the account, or anything else. That's it for today. Thank you for watching. I hope you enjoyed this video. I know it was a really long one, and you'll find all the references in the description box below. Have a good evening or a good day and a good week, and until next week, bye.